This discussion is about simple linear regression and how to interpret the linear regression model. How to what is simple linear regression? It is a statistical model uh, that models the relationship between two variables. The two variables are called as dependent variable, independent variable. So, dependent variable is also called as the target variable. So independent variable is the predictor variable. So based on the independent variable, target variable is predicted. This linear regression model assumes a linear relationship between the variables, and it is represented by the equation y equal to mx plus b, where b is the y-intercept and x is the independent variable and y is the predicted value or target value, where m is the slope, or we can say it indicates the rate of change in the target variable. So in the context of a simple linear regression, the terms coefficient of determination and the significance are the essential concept which assess the quality and the reliability of the linear regression model. This graph represents the linear relationship between the two variables, age and height. You can see that uh, as the age increases, even the height of the children increases. So age is represented in terms of months and height in terms of centimeter. So you can see that as age increases, even height also increases. You can see if you join all the points, you will get the straight line which connects all the points. So we can say that there is a linear relationship between the variable age and height. So in our programming language, we can implement linear regression. So using the predefined function called LM, this function takes the variables in the format LM. Then we have to define target variable and the predictor variable. Then the second argument is going to be the data source. So from where the source of data, using that the model creates a linear regression model. So we are going to predict the target variable based on the predictor. So the LM function takes two arguments, that is target predictor, then the data source. So to create a linear regression model, first we have to read the data source, then we have to pass the data source to the linear regression function. So to read the Excel file, so first load the library, read Excel. If it is using the function read Excel, so we can read the data that is called data source. We have data in the XLS file called age and height, and it is available in the sheet 2 of the worksheet. Then LM. So we define linear regression model using the function LM. So we are going to predict height based on age. So age is going to be the predictor, height is the target variable. And we have defined the data source as data equal to age and height. And this model is created and it is assigned to the variable LM, right? Then we are displaying the summary of the linear regression model, which is available in the variable LM height. The left side you can see some numbers with the measures like Hall, residuals, coefficients, then multiple R squared, R statistics. So in that we are going to discuss few terms. That is how to interpret those terms. Those terms. Coefficients. First, let us see coefficients which are highlighted in the rectangular red color box. You can see the y-intercept is calculated as 64.9283 and the age is calculated as 0.6350. So what is this value represents? For every in every I mean the age, the height of the height of the children will increases by the unit 0.63 for every increase in the that is increase in the age in terms of month. So in this case, suppose if you want to predict the height of a child with the 20.5 months old, So how we can calculate? So the intercept is 64.92 plus, then the rate of change is 0.635. And what is the age of the child? It is 20.5. So 0.635 into 20.5. So the model predicts the height is 77.993 centimeter. So this intercept and age is, the intercept is nothing but in the straight line equation, it is known as b, and age is going to be the m. That is the rate of change in the height. Now, we can also predict the height of the children using one more feature or one more variable called number of siblings. Then the equation is going to be in the form of y equal to a plus age into b1 plus number of siblings into b2. That is, a is here in this equation. The height is defined as a function of age in months and the number of siblings the child has. So age into b1 plus number of siblings into b2. So we are the linear regression model. It calculates the rate of change in age and the rate of change in siblings. So you can create a linear regression model using the library LM, then pass the predictor variable and the target variable. So here we are using two variables to predict the height. So height, age plus number of siblings. So you have to use plus operator. So when you are using more than one variable for prediction, then data source as defined as data equal to age and height. So now this function creates a linear regression with two variables. And to review the results of linear regression model, call the function summary of the model name. So you will get the output as call coefficients and the residual standard error, multiple R squared and R statistics. This is the output you will be getting. So when you are predicting the target variable based on more than one dependent variable, then the model is called as multiple linear regression. So you can see that the values which is highlighted in the red color rectangular box. So age 0.6516, the number of siblings minus 0.01137. You can see that there is a change in the magnitude for number of siblings. So what it says that uh, so, I mean, the height increases in 0.63 centimeter for every month the child has. The same way, when comparing children with the same age, the height decreases in 0.01 centimeter for each increase in the number of siblings, because there is a negative sign. So we got to interpret that the height decreases in minus 0.01 centimeter for each increase in the number of siblings. This is a kind of uh, so so it is a negative correlation. So even we can also predict or interpret the linear regression model output using p-value coefficients. Uh, Here, the p-value coefficients are highlighted in blue color rectangular box. You can see that for age, it is given as for age it is given as 4.34 e minus 10, and for number of siblings it is given as 0.851. So that means the p-value indicates whether or not you can reject or accept a hypothesis. So in this case, the predictor is not meaningful for our model. The p-value for age is 3.4 into e minus 10, or we can read as 0.00000000434. It's a very small value. It means that the age is probably an excellent addition to your model. And similarly, the p-value for number of siblings is 0.85. So there is an 85% chance that the predictor is not meaningful for the regression. So how to test whether a linear model has a good fit or not? So we can use the measure called coefficient of determination, or R squared. So this measure is defined by the proportion of the total variability explained by the regression model, and it is calculated as R squared equal to 1 minus sum of squared difference between observed value and the predicted values from the regression model divided by SSTOT, which is nothing but the sum of square difference between observed value and the mean of the observed values. So this formula can also be written as 1 minus summation of yi minus yi cap the whole square divided by summation of yi minus yi bar the whole square. In this formula, yi is the observed value. So yi cap is the predicted value and yi is the mean of the observed value. Consider this example where for 5 samples, the number of studied hours given for 5 students and observed test score also given. Predicted value is also given. Observed score is denoted by yi. The predicted value also given. So for this sample, first we have to calculate the SSRES, that is residual sum of square. Then we have to calculate total sum of squares. Here, the total sum of square is calculated. SSTOT equal to the square difference between observed value minus predicted value. That is for all the values. Then finally, sum all the values, you will get 770. Then calculate the residual sum of errors. This is nothing but summation of square difference between observed value minus predicted value. So we'll calculate, we'll get 250. Then finally substitute in the formula r squared equal to 1 minus 250 divided by 770. We will get 0.6753. So that means 67.53% of the variance in test score is explained by the number of hours studied according to this model. So the remaining 32.74% of the variance is due to other factor. So that means that 67.53% of the variance in test score among the students can be explained by how much they have studied. So for any linear regression model, you can say if R squared is near to 1, then you can say that the model fits the data well. If it is if R squared value is near to 0, then you can interpret that the model fits the data poorly. If it is 0.5, then the model is considered good in fitting the data values. So then one more term in the output, you can see there are two values are there with respect to R squared, that is multiple R squared and adjusted R squared. So multiple R squared cannot increase when you add more independent variables to your model. So the value is continually increasing when you make the model more complex by adding more independent variables. So for this reason, it is better to consider adjusted R squared value, as if you are adding more than one variable to the model, since it only increases if it reduces the overall error of the prediction. So it is better to consider adjusted R squared value, adjusted R squared value in testing the quality or the reliability of the linear regression model. So then one more term measure we can use to test the linear regression model, that is significance of test. So for that we can have null and alternative hypothesis. So null hypothesis says that there is no relationship between x and y. Alternate hypothesis says that there is a significant relationship between x and y. So how to interpret this from linear regression result? So consider the p-value. So here you can see the p-value for ages, it is 0.000000000434. It is a very small value and it is less than the significance level. That is, significance level is assumed to be 0.05%. So if p-value is less than the chosen significance level, that is alpha, so it suggests that the relationship between x and y is statistically significant. Otherwise, the relationship between x and y is not significant. So after fitting the regression model, maybe a t-test is used to determine if p1 is significantly different from 0 or not. So this result in p-value. That is what it is given in the summary of linear regression model. So which indicates the probability of observing the data if H0 is true. So based on the significance level, so we can conclude that whether the relationship between the two variables is significant or not. Yes, thank you.